Welcome to podcast episode of Emerge Tech AI Tool Talks. I am your host, May Weather. Today, we're diving deep into the exciting world of retrieval augmented generation, also known as RAG. What is RAG? Imagine a system that combines the power of search engines with the creativity of large language models. That's RAG in a nutshell. It retrieves relevant information from external sources and feeds it to a language model to generate a more comprehensive and informative response. Why is RAG important? Traditional language models can sometimes struggle with factual accuracy or lack context. RAG solves this by grounding the generation process in real-world data. This leads to more reliable outputs, making it perfect for tasks like question answering, summarization, and even creative writing with a factual base. Exploring RAG architectures. There's no one-size-fits-all solution when it comes to RAG. The architecture you choose depends on your specific needs. Here's a breakdown of the most common types. Single-pass RAG. Single-pass RAG is a streamlined approach where information is retrieved once and passed to the generation model. It's fast and efficient, but might not be ideal for complex tasks. Single-pass RAG. Imagine it as a quick visit to the library. You ask the librarian for a book on a topic, she grabs the most relevant one, and you're on your way. It's straightforward and efficient. Various tools in the market for this RAG architecture are OpenAI GPT with Bing Search. This tool retrieves information from the web in a single step, much like our librarian grabbing the first book she sees on the shelf. Haystack by DeepSet.ai. An open-source framework that retrieves documents and hands them off to models like BERT or GPT for processing, simple and speedy. Google Search Plus. Palm. Google's experimental combo that pulls search results and generates answers in a single pass, just like a quick library lookup. Multipass or iterative RAG. Multipass or iterative RAG refines the retrieval process by going back and forth between the retrieval and generation steps. This leads to more accurate answers, but can be slower. Here, the librarian works with you iteratively, fetching a book, discussing it, then fetching another based on that conversation. It's all about refining your search. Various tools in the market for this RAG architecture are Facebook's RAG. This model refines answers over multiple retrievals, akin to a librarian bringing you several books until you're satisfied. LangChain's generative agents. These agents allow for iterative improvement, making your AI assistant more like a research partner. Docker QA. An initial tool by Facebook that iteratively goes through documents, much like sifting through multiple books for the right information. Generator-in-the-loop RAG. Generator-in-the-loop RAG is where the language model plays a more active role, guiding the retrieval process to find specific information it needs for better generation. Imagine a librarian who not only fetches books, but also writes new pages based on your discussion. That's generator-in-the-loop RAG. The generation model actively guides what the librarian retrieves next. Various tools in the market for this RAG architecture are Deep Pavlov RAG. It integrates the generator with retrieval, making the process dynamic and context-aware. Hugging Face's RAG with guidance. This tool allows the generator to steer the retrieval, much like an interactive session with our librarian. LangChain's prompt-based search integration. Here, the language model's prompts influence what information is retrieved next. RAG with dense retrieval. RAG with dense retrieval uses dense vector embeddings to understand the semantic meaning of text, leading to more accurate retrieval even for synonyms or paraphrases. Dense retrieval is like visiting the semantic library, where books are organized by ideas rather than titles. Dense retrieval RAG uses embeddings to find information based on meaning, not just keywords. Various tools in the market for this RAG architecture are Pinecone, a vector database that helps our AI librarian find books based on the concepts inside them. Face by Facebook, an efficient library system for similarity search, ensuring the librarian picks books related in meaning. Weaviate and Milvus. Weaviate and Milvus are also vector databases that enhance semantic search in our AI library. RAG with sparse retrieval. This relies on traditional keyword matching techniques, making it efficient for large datasets, but potentially less accurate for nuanced searches. In sparse retrieval, everything is organized traditionally, by author, title, and subject. Sparse retrieval RAG relies on keyword matching, just like our librarian using the card catalog. Various tools in the market for this RAG architecture are Elasticsearch, a powerful search engine that helps retrieve documents based on exact terms. Apache Solr, an open-source platform that uses traditional indexing to find what you need. Whoosh, a lightweight search library for smaller collections. Think of it as a local library's catalog system. RAG with hybrid retrieval. RAG with hybrid retrieval combines both dense and sparse retrieval methods, offering the best of both worlds in terms of accuracy and efficiency. What if our library combined both semantic and traditional systems? That's hybrid retrieval RAG, leveraging the best of both worlds to find exactly what you need. Various tools in the market for this RAG architecture are Haystack with hybrid retrieval. It uses both Elasticsearch and FAS to cover all bases in document retrieval. OpenAI plus Pinecone, combining OpenAI's models with Pinecone's vector search for a comprehensive retrieval system. Zilliz, an open-source engine designed for hybrid searches, making our librarians smarter than ever. End-to-end RAG with closed-loop feedback. The most advanced architecture is the end-to-end RAG with closed-loop feedback, which functions like a learning library. Here, every interaction you have with the librarian helps improve the library itself. Various tools in the market for this RAG architecture are LangChain Feedback Loop. Allows the system to learn from each query, refining both retrieval and generation. Meta's RAG with feedback mechanism. Integrates user feedback to enhance future responses, making the librarian more insightful over time. Microsoft Azure OpenAI plus Cognitive Search. Combines powerful AI models with feedback loops to continuously improve the search experience. Choosing the right tools. The good news? There are many powerful tools available to build your own RAG system. You saw a glimpse into some popular options categorized by architecture type. Beyond the basics, knowledge graphs and RAG knowledge graphs are structured representations of real-world entities and their relationships. When combined with RAG, they provide a powerful way to generate outputs grounded in factual data. This is particularly beneficial for tasks like question answering and building intelligent chatbots. This is like a special section in our library, the knowledge graph. It's like a map of interconnected books, where the librarian not only knows each book, but also how they're all related. Entities and their attributes are linked, so asking about Apple immediately connects you to iPhone, MacBook, and more. Exploring Kotemon, a promising tool for document-based RAG. Kotemon, an up-and-coming tool that excels in handling complex documents with advanced citation management, much like a specialized librarian for academic research. At Emerge Tech, we were particularly impressed by Kotemon for its innovative approach to the knowledge graph RAG. Picture a librarian who not only finds the book, but also highlights the exact chapters, figures, and tables you need. Wrapping up, Retrieval Augmented Generation opens exciting possibilities for AI applications. By understanding the different architectures and available tools, you can unlock the power of RAG and build intelligent systems that are both creative and reliable. Do you have any experience with RAG? Share your thoughts and questions in the comments below. And don't forget to like and subscribe for more insightful discussions on cutting-edge AI tools. Until next time, keep exploring, keep innovating, and let's shape the future of technology together.